Good morning, everyone. We are going to do the lab isotopes and atomic mass, and we are going to find the average atomic mass of vegium, which is a fictitious element, obviously. And using the three isotopes of vegium, we are going to be able to calculate that average atomic mass. And if you look in the little window on the side, the bottom of the screen, you'll see the three the three isotopes of vegium, the total sample. And you'll see that there is a count number, how many of each there are, and there is a mass amount for each of those isotopes. And I have already inserted those values into our table here. So what is it that we need to do? If we read our procedure, we obtain our sample of vegium and we separate them into the three isotopes, beans, peas, and corn, helium, cornium, and rhenium. And we measure the mass of each isotope, and then we count the number of each isotope, and then we put it into the table. And we then have to do a whole bunch of calculations. So the first thing we do is calculate the average mass of each isotope by dividing its total mass by the total number of particles. The total mass is 59.7, and the total number is 451. So our mass, the unweighted average mass, is 0.132 grams. And then it says calculate the percent abundance of each isotope by dividing its number of particles by the total number of particles and multiplying by 100. You're simply finding the percent of each of these values. Oh, we didn't calculate average mass. I apologize. I did the total over here. So this number actually does not go there. We'll use that number later. Average mass. Total mass divided by total number of particles. 17.7 divided by 196 is 0. Did I do my math right? 17.7 divided by 196. Yes, I did my math right. 0.0903. And 9.6, whoops, typing it in the wrong spot, divided by 27 is 0.3556. And 32.4 divided by 451. And 59.7 divided by 451, which is the number we got these for. So the percent abundance, and the word abundance is just telling us how often it's found in nature. So we need to divide the total number of each isotope by the total number of the sample. So 196 divided by 451 times 100 gives us our number here, 43.46%, and 27 divided by 451 is times 100 is 5.99. And our last one, 228 divided by 451 is 50.55%. And our total is 50.55 plus 5.99 plus 43.46. Wow, exactly 100. That's excellent. Now, relative abundance. Calculate the relative abundance of each isotope by dividing the percent abundance from question number 2 by 100. So we just divide each of these numbers by 100. And then it says calculate the relative mass of each isotope by multiplying its relative abundance from number 3 by its average mass. So the relative abundance here, 0.04346 times the average mass of 0.0903. So 0.4346 times 0.0903. And we get 0.0392, that's digits, 0.0599 times 0.3556, 0.021, and 0.5055 times 0.0718, 0.036. And the next thing says calculate the average mass of all Vegium particles by adding the relative masses. This average mass is the atomic mass of Vegium. So we add these three numbers. 0.0392, oops, I keep forgetting that's not my calculator, 0.0392 plus 0.0213 plus 0.0363, and we get 0.0968, which is very low. The unweighted average is this value, the unweighted average, 0.0132. And our weighted average is 0.0968. So you can see the difference here. I'm going to check my math though, because usually they're a little closer to the same. So these are our numbers, and now that you have these numbers and you know that you can count on them, you can now use them to answer the discussion questions and your conclusion questions. So it always is in your best interest to check your work, because I found why my numbers didn't look right to me. And you can see the red highlighted numbers. I made a mistake. So first mistake. 32.4 divided by 228 is not 0.0718. It is, let me change the color and change the number, 0.1421. That's my first mistake. And then this was also a mistake. This one's a little easier to fix. I just put my decimal in the wrong spot. And I believe this number was a 0 after it. So I'm going to leave this red just for now. And then, so these numbers down here are all going to be different. So now, multiply 0.1421 times 0.5055, and we get, oh, I want this to be blue, sorry, 0.0718. And when we add those three numbers up, we get 0.0392 plus 0.0213 plus 0.0718 is equal to 0.1323. And I'm going to check this last digit here. 59.7 divided by 451 is actually 0.13237, so that becomes a 4. Actually, I can just do this, 0.1323. So I've done this lab often enough to know that these two numbers should be the same or very close to each other. So when they were not, I knew I did some math incorrectly. That comes from experience, having done this lab before. You, on the other hand, have not done the lab before, so you wouldn't know that those two numbers should be very similar to each other. But again, it always is in your best interest to check your math.